Good morning, Year 10s. How's it going, everybody? Right, chemical tests. I love the fact that Jack finally made it in first. Jack, I nearly sent you the link to the YouTube. How's it going, everybody? I nearly sent you the link first because I was like, Jack has been trying to get in first on the chat forever. He's never made it, and he's finally done it. Well done, Jack. Congratulations. Oh, amazing. Right, so today we're starting chemical tests. I'm just going to quickly grab my learning objectives. So this is a new topic. Lots of practicals to do. By the way, this is actually still a continuation of Ionic. I'm going to do a little bit of around it, but it's still actually a continuation of Ionic. So this is chemical tests. Chemical tests, lesson 1. Lesson 1. Amazing. Right, and it's actually focusing today on cations. Cation tests. Let's now paste in my learning objectives. Right. So it's all knowledge now, folks. It's actually quite an interesting thing, isn't it, to see my learning objectives and to recognize that all of these are knowledge-based. Yeah. Chemical tests is a tricky subject for students because they've just got to flat out learn this stuff. There's very little understanding required. I'll give you a little bit of understanding, which goes a little bit into A level. But just to explain to you where the colors actually come from. But unfortunately, guys, this is about learning this stuff. You've got to know it. The be able to's, the A's in my learning objectives will be in the practicals when we're doing them in class. So, and they are tricky because there's actually there's a slight difference between what I teach you guys in theory and then the actual practicals being done. There are subtle differences that just need to be discussed in that setting. So, did someone dislike my video already? Wow, that was fast. That's a bit sad, isn't it? All right. Okay, so let's crack on. I'm going to share my screen. I've also got a new webcam as well. So share screen. And then I'm actually going to switch up. I've got a new webcam because now I'm trying something new. I don't know if I know if it's any good doing this. Way! So I can stay on the video so I can do all my dancing around. Yeah, let's delete that. I can do my dancing around, and you guys, you'll see me writing most of the time, but I can still do any little animations that I need to. Okay, so hide share. I can get rid of that now. I can get rid of my YouTube stream because I've popped out the chat. They do it well. There we go. Right. Okay, so chemical tests, 3 learning objectives. So, like I said, this has a particular focus for Ionic. I'm actually going to rope in some organic, some covalent tests as well. But chemical tests, we're going to do in a whole series of lessons. I'm just going to focus on the ionics. I'm going to get the ionics bits done first, then we're going to drop into gases, and then we can plod on from there. So the first thing we're going to be doing is testing for cations. So we all know that, so this is a quick revision, nota bene. Yeah, ionic compounds contain cations, the positive ions, and anions. Yeah, they contain both of these. And what there is a set of tests for both these people. So today we're focusing, number 1, on cations. Now there are 2 tests for cations, just 2, that's it. So the subtitle today is cation testing. Cation testing. So I think it's very reasonable to do a little bit of revision on some naming of ionics. So if I just go NaCl and then Ki and then maybe do Ca brackets NO3, 2, and then maybe do Li2O. There we go. So you guys know how, and you guys should all understand how these formulas are now built now. Yeah. What we're doing is we're doing the Na plus and the Cl minus using our cross and down, although I don't like it. The ones disappear. Yeah, you should all know how these are built. Yeah, you should all understand this. But what I now want to do is what I'd like you to do is to name them all. So can you now give me the name of each of these, please? So write down the examples of these ionics and then just give me their names over there. Yeah, it's just nice for me to And then what we can also do is then say, what's the cation? What's the cation? You can give name or formula there. And what's the anion? I think it's very reasonable for us to do this, to break down some ionic compounds. There we go. So guys, I like it. Gayatri, thank you very much. Giving me the first name. So guys, pause the video, fill out the table. That would be great. You can fill that out in your notes, and then you can mark it as we go. So this is going to be out of 12. So the name here is sodium chloride. I can't believe I bust my pen. All the things to shove into my little... I've got a little fan that sits on my desk that cools down my laptop. And unfortunately, I managed to catch the end of my pen in it. Sodium chloride, the cation is the sodium ion. Notice, by the way, I'm not writing sodium. I have to write down the word ion. Yeah, brackets Na+. And then the anion is the chloride ion, which is Cl-. Yeah, oh, didn't quite do it as well with that. That's my new bust pen now, causing me trouble. There we go. And then we've got potassium iodide. Cation, of course, is the potassium ion. K+, and the iodide ion, which is I-. And then this one is calcium. This one's is a bit more challenging. Calcium nitrate. Well done, Callista. Good job. I love the fact that she's giving Gayatri number 4. Well done, yeah. Calcium nitrate. So the cation is the calcium ion, and its charge is Ca2+ from the periodic table. We know how to use my table now. And the nitrate ion is NO3 1-. You've just got to learn that. It's a complex ion. We've done them. You've got to learn it. Next one, name lithium oxide. We realized the metal never changes its name, but the anion does. The cation is the lithium ion, which is Li+. And then the oxide ion being the anion of O2-, which we get from the periodic table. The only one there of any difficulty was that guy. He's the only complex ion, and we've got to know their names and their formulae. Guys, got to remember them. I'm just at this point going to get you guys, because I've not seen you in 3 weeks, I think it's very reasonable, since I haven't seen you in 3 weeks, we need to run through those complexes again, because everyone's going to have forgotten their complexes. So what I'm going to do, let's do complex ions. It's always good to revise. Complex ions, we have the nitrate ion. I'm just going to put ion up there so we don't have to keep writing that. So, and its formulae. Yeah, you can put on that one there. I want its charge as well. Don't forget its charge. Next one is the hydroxide. Formulae and charge, please. Next one is the carbonate. Carbonate, there. Then the sulfate. Sulfate. And then for those people who are thinking of doing A-level, phosphate. That is an A-level extension. Yeah. And then we have ammonium. Yeah, ammonium. There we go. And again, these are actually very useful for GCSE, but they tend to be provided to you, but not always, not always. Silver, not complex, of course, transition metal. And then lead, and then mercury. These are really good ones to know. It's not A-level, really, but handy for GCSE. Silver's actually a really important one for iGCSE. Lead and mercury, not so much, but they do appear every now and again. Very rare, but they do. Level 8 and 9 questions. Right, so pause the video, fill in the formulae, and then we're going to mark it. So just out of curiosity, that first one was out of 9. Can I have everyone, please, in this chat? Everyone who's in this classroom right now. How many people are watching? I don't know because I closed my YouTube video. Ah-ha! Can I have everyone please tell me out of 9 how many you got on that first activity? How many did you get? Just give me out of 9. Next, and then this one's going to be out of 9 as well. Isn't that nice? Yeah. So just give me an out of 9, what you got on the first one. Pause the video, fill it in, and then unpause it when you're ready. So the nitrate ion, NO3 1-. Hydroxide, OH 1-. It must be capital letters. Please bear that in mind. Carbonate, CO3 2-. Sulfate, SO4 2-. Notice how I do this. Oh, Callista, so close. So close on the phosphate. PO4 3-, the only 3-, but it is an A-level extension. Good effort though, Callista, well done. Yeah, and then ammonium, NH4+, the only complex positive ion that you guys need. It's not the only one in existence, but it's the only one that you're going to need at GCSE for sure. Silver is Ag+, lead is Pb2+, and mercury is Hg2+. And we're done. Oh, I love it. Zinc, 2+. Zn2+. You can do it out of 10 if you like. There you go, out of 10. Actually, no, because I just gave you that one really quick. My bad, just ignore that one. I'll leave it on there. You can add it to your notes. Zinc is another useful one to know. It's always +2, but it's out of 9 because I've given you the zinc one. 9 on both. Signer, well done. You star. Good job. I'd like to see everyone please posting their numbers, please. Come on, guys, contributing on the chat, showing me. I know that you've paused it. So I'd like to see, once you've unpaused it and you marked it, please post your numbers. Okay. What a great bit of revision that is on ionic compounds. Okay. So what we now realize is that we're going to get given, leave that there for a second. Okay. So all ionic compounds are solid at room temperature. At room temp. Full stop. 9 and 10, well done, Jack. Gayatri, 9 and 7, well done. Henry, 9 and 8, well done. Lauren, 9 and 8, well done. Callista, 9 and 8, well done. Good job, guys. And solid at room temperature. And most are white. So, but we need a bullet point here. So if number 1, all ionic compounds are, we can do facts if you like. Facts. Number 1. All ionic compounds are solid at room temperature. Number 2. All group 1 and group 2 ionic compounds are white. Now I need to show you what that means. That's less understandable. Yeah, so all of the compounds that I gave you up here, all 4 of these will be solids at room temperature. All of them have the state symbol S. Yeah, we know this. And in fact, it turns out they're all white as well. Look at that, because they all contain either a group 1 or group 2 metal. So they're all white. So sodium chloride. Oh, my pen. Oh, I broke my pen. I can't believe that. So upsetting. Sodium chloride is a solid at room temperature, and it is white. Let's just check that out. It's always nice to prove a point. So sodium chloride. There we go. It's a white ionic solid. I think everyone would agree with that. Next. The next one we had was potassium iodide, Ki. Ki will be a solid at room temperature, and it's going to be white. I can predict these. How cool is this? All of them. Potassium iodide. Here it is. And it's a white solid. Winner. Hello. So it's white. Next, calcium nitrate. Oh, it contains a group 2 metal. This one here is group 1, Gr1. This is Gr1, group 1, so white. This is group 2, so it must be white. Love it. White solid. Let's have a look at what calcium nitrate looks like. I always like proving stuff. Chemistry is awesome because that's like the rules kind of, you don't need to learn it all. Group 1 and Group 2 ionic compounds are all white. How cool is that? Calcium nitrate. It's going to be a white solid. Hello, Mr. White Solid. There we go. It's a white solid. And the last one was lithium oxide, which is going to be, and would anyone like to guess what color this compound's going to be? It's going to be a white solid. Let's have a look at lithium oxide. I'd always like to, you know, as a teacher, I'm here to facilitate the learning, but it's there for me to be able to show you guys that this is what, I'm not just making this up. Oh, some people are going to go, looks a little bit yellow to me. There you go, white. Okay, so, and that's of course a group 1. So we can now do a whole load of others here, and we can just make predictions. And this kind of comes into my fact, that should be fact number 2. So fact number 3, where do colors come from then? When do we see colors? So ionic compounds containing transition metals. Transition metals often have colors. So they form colored compounds. Now, by the way, the word often, I should actually just say has color here, but actually there are times when they don't have color when they're anhydrous salts. We'll come across that later on because that's actually the test for water, and we'll come across that later. But what you need to know is that transition metal ionic compounds have colors. So let me show you some. There is iron 3 chloride. Now notice the Roman numeral being, oh, my pen is, the top of the pen is now just falling off. It's an absolute disaster. I split it. The fan hit it and just cut it. I need to like get a little bit of super glue on it, I reckon. I might do that. So this is, now notice the Roman numeral appearing here, folks. Now, I'm just going to give you guys a quick revision lesson on why the Roman numeral is there. The reason being is it's telling us the charge. This here tells us charge. By the way, the proper name for charge in chemistry is called oxidation state, just to tell you, an A-level extension, tells us charge on metal. Yeah? So in this case, it's telling us that Fe is in a +3 oxidation state. Yeah? And I know that because the chloride is always 1- from the periodic table. Yeah? So if we now do another one, so let's do copper, let's do copper oxide. Yeah? Well, it's going to need a Roman numeral. I wonder if anybody would like to tell me what the Roman numeral is for this. That's a tricky one, that. Impress me, year 10. Like, seriously, impress me. I can't believe I bust my poor little pen. And get some super glue out and see if I can glue the tip back on. Oh, it's going to fall off. So expensive. Ian, you're a legend. Well done, Ian. So impressed. I'd love you to tell me how you did that. And he's absolutely right. This here is copper 2 oxide. The reason being is that the oxygen in this compound, oxygen is always -2 from the periodic table. Oh, except, by the way, there is one exception. I did it from memory. That's fair enough, Ian. Copper 2 is the most common. You're right. There is copper 1. It does exist. But oxygen is -2. There's one exception where oxygen isn't -2, and that's hydrogen peroxide. That's a nota bene. Nota bene, H2O2. Hydrogen peroxide. Hydrogen peroxide contains O1-. That's a nota bene, that, folks. Really important for Edexcel too. Oh my God. But all the other times, it's 2-. What that means is, for us to have an overall charge of no charge, that must be bringing Cu2+, because the charges now cancel out. Cancels, to give us no charge at all on the formula, on the molecule. Oh, that's not molecule, on the ion formula, technically. So that's iron 2 oxide. Now, the great thing is these now both contain transition metals, so they're going to have colors. And I'm going to tell you that the iron 3 chloride, this one, I'll get rid of those colors up there. The iron 3 chloride is going to be yellow. Yeah, it's going to be a dark yellow because I'm going to show you a picture and it's going to be a solid. It's going to look like this. Yeah, it's yellow. And the copper oxide is black. Jet black too, really black. Copper, let's prove it. Iron 3 chloride. Iron 3 chloride. Nice. Take that. Images. There you go. It's a yellow solid. Looks darker because it's very concentrated, but it's a yellow solid. And yes, I know my colors. Guys, you just have to know them. Yeah, the next one is copper oxide. Copper 2 oxide. Copper, not Copenhagen. Copper 2 oxide. No, that's copper 3 oxide. Don't want that. It's not even a thing. Copper 2. There we go. Copper 2 plus. Copper 2 oxide is black. And you've got to know them, guys. You've just got to learn them. There are going to be, oh, you're going to ask me how many colors do we need to learn? About 20. It'll be fine, I promise. But we can now predict when they're going to have colors, but based on the metal in it. These two are both colored. Have color due to containing Fe3 plus and Cu2 plus transition metal ions, TM ions. I like it. So we can do all these predictions, which is really cool. Okay, so what we realize is that if you were to know your colors really, really well, let's just have a thought experiment. Let's say somebody gives you something, gives you a bag containing a powder, and the powder has a color. Well, you're immediately going to have an idea about what that's probably going to contain. You need to check to see whether or not it's ionic or covalent. That would be the first test I would do. By the way, it's a really easy test. You burn it. If it burns, it's covalent and organic. If it doesn't burn, then it's ionic. In which case, if it's colored, it's going to contain a transition metal. Don't eat it. Very poisonous. Transition metals are fully toxic, like crazy toxic, heavy metal poisoning. And I have been poisoned myself from it, by the way. It's not very nice. But the problem is when you get given a bag of white powder. Yeah, let's say somebody hands you a bag of white powder, and let's avoid all the jokes. Yeah, but this is a thing, you know, when you turn, you know, the classic scenario is the crime scene. You know, they turn up to a crime scene and they find bags of white powder, and you see the guy stick his finger in it and you know, we don't do that anymore. That's madness. I'm always waiting for the day when I'm watching a police cop show and the guy sticks his finger, oh, yeah, cyanide, and then just drops dead. It's just we don't do this. Nice, Ian. Nicely done. Crack. Brilliant. Yeah. So we don't taste it. We do chemical tests. And actually, the first chemical test that we tend to do is we're going to do what's called a flame test. And this is tests for cations. Okay. So, subtitle, please, folks. Testing for cations. Testing for cations. Okay, 2 tests. Test number 1. Test number 1 is a flame test. A flame test. Test number 2. Test number 2 is sodium hydroxide solution. 2 tests, that's it. 2 tests. 1, a flame test, and the second, a chemical test where you add 1 substance, and that is it. So what I now need to do is I now need to teach you each one of these in turn. Because why would you need 2? The reason being is 1 doesn't do all, which means we need to have multiple tests. So what can a flame test for? So first thing we need to do, so subtitle, flame test. And actually, I'm not going to do the sodium hydroxide solution, that's next lesson, but flame tests we can certainly do. So, flame test, what we're going to do. So, first of all, we're going to need a method. So, we are given a piece of paper, and on that piece of paper is a white solid. I don't like the fact that it's going through that. I need to do the picture better. We're given a white powdered substance. Yeah, a white powder. And someone says, whoops, not powder, white powder. And someone asks, what is this? Question mark. So, first step we're going to do is check for the cation. And as I said, this is done doing what's called a flame test. It's very straightforward. Bunsen burner, blue flame, and a nichrome wire. Let's draw that out. So what we're going to do is step number one. Step one is I am going to get myself what's called a nichrome wire. So this is literally what it looks like. I'll find a picture of this in a second. And this is nichrome wire. By the way, it is an alloy of nickel and chromium. And the reason why we use it, nichrome wire, or nichrome loop, sometimes said, nichrome loop. Nichrome wire is better, prefer that for chemistry. Yeah, and we use nichrome. Nichrome has a high melting point, high MPT, and is very unreactive. What we don't want to do is we don't want to put a metal in mix a substance that's reactive here, because if it was reactive, it's going to change the substance we've got on the table. So we need this to be really high melting point so we can stick it in a flame, and we need it to be unreactive so it has no impact on the solid we're testing. Seems reasonable, right? Right, so step number one, nichrome wire. And what we're going to do is we're going to dip the nichrome wire, we're going to dip it into hydrochloric acid, HCl. So step number one is a washing. Step one, washing nichrome wire in HCl. Washing nichrome wire in HCl. Now, all we're doing here, folks, in this first step, all we're doing is removing any previous tests, because we don't know whether or not this has been used before. Previous test residue. The word residue simply means like leftover solid. Like, so if you have a cup of coffee, you often find that when you get to the end of your cup of coffee, there are bits of coffee beans in there, and that's your residue. It's the solid left behind when you take out the liquid. Yeah, so it's left behind solid. Previous test residue, leftover solid, leftover solid. Maybe they hadn't washed it afterwards. Right, now that we've washed, by the way, I'm going to show you what a nichrome wire looks like. So nichrome wire flame test. Let's have a look at what it looks like. And there it is. Oh, what a better picture. Hey, look at that. Literally is exactly what I drew. So we've got the nichrome wire. We've got the there we go. Nichrome wire fixed on the end of something we can hold. Now, usually the end of it is either metal or plastic, something that doesn't conduct electricity. This one's glass by the looks of it. Something that doesn't conduct the heat very well, because you don't want to hold onto a piece of wire and stick that piece of wire in it, because the wire is going to get hot. So it always has a handle, so to speak. This is why you can see, you can see exactly what he's doing there. Yeah. So now the next thing is, now that we've washed it in HCl, Step two is pick up solid to test. So this one's really easy, because the great thing is the solid that we've got on the paper, the solid that we've been given, is going to stick to the nichrome wire, because the nichrome wire is now slightly sticky because it's covered in HCl. Yeah? So we're going to pick up some of the solid onto the end of my nichrome wire. Just going to pick up a small amount. Don't need much. Yeah? Pick up solid. Step number 3. we're now going to place wire into a roaring, notice my capitalization, blue flame. So this step, let's try and do this as best as possible. So we've got a roaring blue flame. So the question to you is, why would you do it on a roaring blue and not a safety flame, not a yellow flame? Yeah, why would you do that? There we go, the solid's on that. We're going to place it into a roaring blue flame. There we go. So the reason for this question, why not yellow flame? The reason being is you won't be able to see the color. Why not yellow flame? Question mark. Answer. Yellow flame will mask. I'll underline that word. I'll write it a bit better too. Mask. The word mask means to cover. Will mask the flame color. The flame color. Yellow flame will mask the flame test color. So all you'll see is yellow. What that actually means is you just see yellow. And if you're trying to pick up a subtle color like lilac, yeah, it's going to be very difficult to see that. Right, so this actually brings us to the end of the method, and the question is, what colors am I going to see? And you now have to be able to learn these. Step 4, colors. Okay, so step 4 is colors. So if you have lithium +1, you are going to see, so this is let's do a table again. So we've got the ion, the cation, even better, cation. I'm going to zoom in as best I can. The cation present and the flame color. Make that a bit better writing. My pen, the broken tip on the pen's making it terrible on the tablet. This is a disaster. Cation lithium 1+ is going to give me the color red. So just to show you what that looks like, it looks just like that. Oh, there's showing strontium there as well. Hey, there it is. Well, hello there. Well, hello. Oh, no, don't want that. No, go away. Go away, YouTube. Images. I just want to zoom in. Copy image. There we go. So at this point, it's nice to see them if it'll let me do it. Trying to find the mouse paste. Yeah, look, and there's lithium. I'm going to change my color so I can see it on here. I think if I do this in like white, maybe, that there, right there, is lithium 1+. The flame will turn red. Right, the next one. Oh, yellow. Sodium. Oh, I'm doing it in white, aren't I? Because I'm an idiot. So Na1+ will give me a yellow flame. So this one here is red, bright red for lithium. And then we get yellow, sun yellow for sodium. So there's sodium over here, Na+. Right, the next one is lilac, potassium. So K+ will give me lilac. And you're not allowed to call it purple. Sorry, guys. Lilac. And right over there is K+. Next. So we're slowly taking them off the list. This is amazing. Next one. So we've now got calcium 2+, Ca2+. And this is orange red. I know that's tricky, guys. Yeah, but it is like, if you look at that picture, it genuinely has this orangey center and red outside. So we literally call that orange red. That's at Excel. Anybody else calls it brick red, but that's for AQA, that there is orange red. Orange red. Quite difficult to see at times. Next one, copper 2+, Cu2+, which is blue-green. So you can probably tell there's two in here, two greens here, but you can tell which one's copper because there's a blue in it as well, which is there after it in white. And you can see that this is definitely copper from the blue-green of Cu2+. Yeah, you are allowed actually just to call it green, which really annoys me, but it is actually blue-green. Let's see if I can find a really good blue-green. It's like that. That's really not what I clicked on, you mean thing. Let's try that again. It literally is a combination of the two of them, really. Yeah. It's quite a bright green, to be fair. I mean, you can actually, let's just zoom out. Yeah, there you go. Oh, yeah, that'll do. So it's a blue-green. Blue-green. There we go. And one more, which is barium 2+. Ba2+, which is green. That one is apple green, or just green in this case. It's quite a pale one, quite difficult to see. I don't do that test in school, by the way. It's because barium's not particularly nice, but you can see the green over there. Olive green, often referred to. But those are your 6 flame colors. Now, the important bit for me to now mention, by the way, I'll add barium onto here, Ba2+, is, so at this point, everyone's like, this is awesome, we get all these cool colors, why can't we just keep going? The answer is, not all metal cations produce a flame color. So magnesium, for example, so this is an important nota bene in red, nota bene, Mg2+, no color in flame test. You can't test for calcium for magnesium that way. You can test for calcium that way, you get your orange red. But magnesium, it's gonna give no change. Now that's a problem. Aluminium is another one. Aluminium 3+, no color seen in flame test. No color in flame test. So we had to come up with an alternative test for these cations. And the fab bit is I now get to just do the fun bit of this lesson. Because now that we've done that, guys, we can now realize how we make fireworks. So fireworks, you guys have all been to fireworks displays, and the cool thing is you see all the beautiful colors, and those colors come from salts. So when they're making a firework, and they want it to have a particular color, they add ionic salts. If you want to, you can also add strontium to the list as well. Strontium is another red one. You don't actually need to know strontium for Edexcel, but they have provided it in the past. They've also done a whole lot of other random ones as well, but they give you the color, so you don't need to worry about it. These 6, you've got to learn. But we can now identify the people that we put in here. So this red one, for example, it's not going to let me write on it. I can do full screen snip. So the red one over here, they're going to have added probably lithium chloride, because the lithium chloride contains the lithium ion, which gives the bright red color in the flame. So it'll just color the flames that are being produced. The yellow color that you can see here and here, that yellow is probably going to be the fact that they've added sodium chloride to this. Sodium chloride contains the sodium ion, which is going to produce the yellow flame. The pale pink up here is going to be the fact that they've probably added potassium chloride. They tend to do the chlorides because the chlorides are easiest to find. There's more chlorides than any other salts, so they use those ones. And then they could have added copper 2 chloride for the greeny blue. Yeah. If you're wondering how they make the bright white and gold colors, the sparkles, they're not adding in salt, they're adding in metals there. Just to show you that. So if you do the actual metal, so magnesium metal sparkles, this is not a magnesium ion, this is magnesium metal, and you get the white sparkle for magnesium. Yeah, but you often see that sometimes you'll get sparklers that are yellow. They're using a different metal. And by the way, once again, emphasis. The sparkling is not a compound, it's a metal. If you want white sparkles, you add magnesium metal, because the magnesium metal is burning to form magnesium oxide and gives off a white color. Yeah, if you burn iron, then you get a gold sparkle. So that's iron metal. And you can see what they're doing over here. We can, by the way, we can actually make some like really basic fireworks in school. We can make things like sparklers. Really nice thing to make. You can actually change their colors and add some cool sparkles to them. They're a lot of fun to do. And we'll have a go at some of that when we're back at school. That actually brings me to the end of my lesson. Let's check my learning objectives. Yeah. Safety precautions. Okay. So safety precautions do need to talk about. Flame tests, of course, do have a couple of points in safety. Number one, so you can put a little subtitle of safety. Safety. So number one, wear goggles. Now, that one, everyone's going to be like, well, that's just kind of common, just kind of understood that, wear goggles. But there's actually a reason for this. The reason being is when you do a flame test and you put the solid into the flame, it can often spit. So this idea of wear goggles to protect against spitting. I know, it just spits, you'll see. When we do this in school, you'll see this. Yeah, protect against spitting. The solid kind of goes, just kind of crackles and pops off. And if you've ever put salt in a frying pan and heated the frying pan up, you'll see it spit out of the pan. It'll jump out the pan. Yeah, that's what you're protecting against. Also, of course, this needs to be done on a heat-proof mat because you're going to have to put down the solid afterwards. So number two, I'm actually going to not add that one to the list because that's always a very specific question. It's not so much a precaution, yeah, rather than it's an in-context question when they do that. So the main thing is wearing goggles to protect against spitting. Obviously, the blue flame is also hot, so you don't want to stick your face in it. But that's the main question that comes up on exam papers. So students performing a flame test, why would he need to wear goggles? You'd say because it could spit, yeah. But the flame test may spit. What would the student do? And you'd say wear goggles. You wouldn't say, you could say put on gloves. You could argue that it could spit onto your hand because your hand's nearer than your eyes are. Totally agreed. And they'd probably allow you to say wear gloves. I can add that one. Yeah, wear gloves in case it spits on your hand. That's not bad. Yeah, so I don't mind that one being on the list. And that brings us to the end of this lesson. And those are all the colors that you need. By the way, other ones that don't, iron doesn't give a flame color. As an ion, remember, as an ion. I'm gonna finish that off just looking at my learning objectives, get to just tick them off. Flame test method, your colors, and your safety precautions. I think we're okay with that today. So that boxes off flame test. And I'm going to end that. You'll have a go at these next lesson. So I'll bring this back to here. There you go, guys. Right, it's been lovely to see you guys, year 10. I hope this has all made sense and you're going to now sit there and learn your colors. There aren't that many, only 6 colors to actually learn for your flame tests. And if you do them bit by bit, you know, and you kind of like build up these sections of colors, it actually makes things a whole lot easier. If you want to come up with a rhyme to remember the flame colors that link to the metal ions that are producing their colors, please do, and please share it with the class. That would be fantastic. Guys, have a good rest of your day, and I'll see you all soon. I'll see you tomorrow. See you later, guys.